Thank you so much for continuing with us in the second day on CBI Meeting. Distinguished leader in biomedical engineering and education, with a solid academic background and a prolific research career. Professor Aspiros has stood out for his leadership in biomedical image and signal processing projects, magnetic resonance imaging, and medical device design. His commitment to academic excellence and his contribution to the advancement of biomedical engineering at a national and international level make him a distinguished leader in the discipline. It's a great admiration and respect that we present Joaquín Aspiros Liham. Thank you.
Thank you for your... Can you hear me? Hello? Can you hear me? Okay. Okay, thank you for your kind introduction. I have been here for many, many years, but I think these kinds of reunions are very important for students to get up there to their English talking skills. And we're going to talk just about bilingualism. So with no further ado, I would ask you please to read this. Read at least the first 3 lines. Have you done it? Raise your hand. What is it about? We don't know what is happening, do we? But we all know a little bit of English. Can't we understand what is happening? Let's try to read the last part. This is a trick question. Why? Because it is well written in English. It is written by a Nobel Prize winner, but it is written in 2 kinds of English. First, it is the stream of consciousness. The author is just writing down what he is thinking about with no structure, just what comes to him naturally. And in the second place, it is a person who is disabled. It is a 32-year-old person with a mental age of 3. So this is why it is very difficult to understand. And for those of you who are not completely bilingual, you're making you work your brain in 3 different areas. So this is very, very difficult. Even in regular English, it is difficult to understand. So what's it about? It's a story about a family and their problems in the 1940s, a very well-to-do family that comes into trouble. But I will let you read the book first. Okay, so the first part is this. Reading is a critical skill for academic and personal success. What does this mean? That no one with low reading skills or who is illiterate can get a good job or a high-paying job. You cannot perform anything. You cannot read a manual. You are basically alone at sea. No one is going to help you. So it is a critical skill. People who have high abilities in speaking and talking in different languages have specific strategic advantages over normal or regular people. So many things have arisen regarding this topic in recent decades. How does the brain of a bilingual person work? Bilingual, I mean, it doesn't matter if it's English or Spanish or French. They can understand it indistinctly. Can a bilingual person really acquire or master 2 language systems with the same competence and ability? Can you really be bilingual? What difference does the brain activation of a bilingual person have compared to a monolingual person? So, as in the example at the beginning, when you're not bilingual and you're reading a foreign language and it is written in a way that is difficult to understand, your brain is working overtime to trying to see what is going on. How much does the age of a second language acquisition influence human language processing? This means, do we have different areas for different languages? What happens if you are dominant in one but not in two? Or if you're all the same, you're completely bilingual. What happens to the brain areas that are activated during reading or talking or writing? And what factors more or less affect the representation and processing of language in a bilingual brain? So here we have like two pictures which are the same. You cannot really see them, can you? Are they well focused? Okay, so it is widely accepted that grapheme to phoneme conversion, GPC, is facilitated by phonological coding and is used to read novel words. What does this mean? Grapheme to phoneme conversion means that your brain first reads the signs that are the letters in a language, and then it converts these signs into sounds. And then you start to understand what you are reading. I don't know if you remember, but people who are starting to read in any language usually speak out the words when they are starting to read. So this is what's happening. You have to have two pieces of your brain that are working together. First, the visual that is translating the graphic part into the zone which is used to hear the words. The recognition of familiar and frequently encountered words involves more direct mapping facilitated by orthographic awareness. What does this mean? It means that if you run into the same words all of the time, your brain doesn't have to go to translate the graphic part into the hearing part. It goes directly to the hearing, and then you know you are practically bilingual, at least in those words. So word reading has been conceptualized under what is called a dual root theory. An indirect sublexical root, sublexical, that requires visual words to be transformed into their auditory counterparts, which is the GPC. And the direct lexicosemantic root that relies on the direct mapping between the visual forms and their meanings. Neuroimaging studies have led to a brain-based model of word readings composed of three parts. And we can see them in the graph below, or if you can read it in the graph above. The memory-based visual word form recognition is the OTC, occipital temporal cortex, below and behind, which is near the visual system. The temporoparietal way of obtaining images is what is called the signals T1 and T2, which give those kinds of responses, and proton density, which is a different kind of mapping, and you can see the results there. It's not important. These are all of the same kinds of images you have already seen. Okay, so magnetic resonance imaging uses electromagnetic fields and radio frequency signals to produce images. You know, there's a great field in the coil, and then you stimulate whatever you're trying to image with radio frequency signals. Part of these signals are attenuated by the brain or whatever structure, and what is left over is picked up also by radio frequency, like a radio antenna. And then we just do complex mathematics to show you the images. So it can show morphological changes by viewing the different image contrasts, which means you can see if there's something that is unusual here, you can see it right away. That's the advantage of MR imaging in the clinical areas. Bold is something different. It's called blood oxygen level dependent contrast. What does this mean? It means that you can also obtain images coming from the oxygenation or deoxygenation of several vessels in your brain. And what is happening is what you can show you here. You see a stimulus and the neuron on your left. Then you have a neurovascular coupling. There are some substances that are not well identified but are generated by the neurons and the vascular coupling, which produce an increase in the size of the arterioles around the tissue that is working. So of course, if you have a lot of things that are working, you use more oxygen. You remember all the Krebs cycle, where you have to convert sugar into energy, and you need oxygen. Well, your brain is needing more oxygen where it's working a lot, and it signals through the neurovascular coupling to open the arterioles that are exactly on top of the neurons that are working hardest. And then you can change this blood that has more oxygen, you can detect and you can show it on your scanner. So this is what is called the bold response. It is functional magnetic resonance imaging, and it has been used for many, many things when it is something related to function, not to form. So here you can see that the contrast is what is being imaged. So when you have oxygenated blood, it has no signal loss. When you have a low ratio of oxygenated to oxygenated blood, you have a slow decrease in the signal. When you have a high ratio of oxygenated blood, then you have a fast decrease in MRI signal. And if you have the deoxygenated blood only, you have no signal. So this is what you can map and register in your images. So why should we be studying bilinguals or people who are learning in a second language? There are a couple of things. First, it is interesting. So there are hundreds of papers, and why is it? Because it is interesting. It gives you insight into what is learning. So it has many uses. And in the second case, bilinguals have been found to have a cognitive reserve, which means that they have reserves that protect people against Alzheimer's, for example. And you start to decline cognitively, but nobody notices because you have your reserve tapped into your brain. You have worked your brain. You have exercised your whole life with your brain. So now, as you start to age, you no longer lose it that fast. So this is what I told you a while back. Functional MRI is the technique that shows brain electrical activity based on the fact that the tissue accelerates its metabolism when it's active. And this change can be measured, and this is a reflection of brain function. So what we are trying to do, our hypothesis is, during silent reading tasks, more active areas can be observed when the proficiency of the L2, the second language, is lower. What does this mean? That your brain is working harder because it doesn't know what it is reading. Remember the first example. In subjects, when L2 is high, the proficiency is high, language processing areas are superimposed. So one of our suppositions, one of our hypotheses was that the two areas were supposed to be blending in when people became bilingual. So our idea at first was to have the people from the English as a second language department provide us with students with the 3 levels that they give. And maybe we could be able to give them an English test without having them taking an English test. Do I make myself clear? Just by reading inside the scanner, you could say he is highly or lower in proficiency than the population. But we couldn't do that. So also this superposition is lower when L2 proficiency is lower. So this is our principal aim. Map the differences in the activation zones of volunteers having competencies in the second language. So we got a group of volunteers that had already passed the 3 levels of language that is that are given out here at the university. We were going to evaluate the competencies in the second language and then perform fMRI acquisitions and see what we can observe. So what we do is what is called the paradigm, which is a block design where we present to the volunteers different words in English and then a block of different words in Spanish, and we try to imagine them and then to see what is happening. And the words have varying levels of difficulty. And the block presentations will be randomized in order to avoid biases. For example, this is an example of block design. Can you read the little letters? More or less? Well, you have alarm, argot, arroz, arroz, array, babor. Different words in different difficulty. For example, here we have one that is very difficult in English, cousin. What is that? It is a small boat that is used for shell fishing in England. So who would know that? Who knows? So that's the idea. Present several of these blocks, and then you can tell them stop and rest or continue. So what we had was university students between forgive me, they're just 20 and 30 years of age. Non-claustrophobic because you have to lie down in the magnet, and not all of the people can support that. Without neurological alterations, without prescription for neurological treatment. We chose people who had the L1, the maternal language, as Spanish, and right-handed. The acquisition was with this equipment, a 3 MRI Philips scanner with a sense antenna and a screen to present the blocks at the end. And these are the parameters: time of echo, time of repetition, and we got 200 volumes in 19 slices. After this, we had to do an analysis of all of the volumes and all of the slices, and it involved first the pre-processing step that requires alignment, normalization, and smoothing of the images, then processing, which means evaluate the contrast between English and Spanish, and then a statistical analysis. So we had 6 healthy volunteers. The average level was finally decided to be B2 according to the Common European Reference Framework. And we had a protocol to evaluate whether he was right-handed or left-handed, because it wasn't only necessary to ask, we had to evaluate this. You know that there are some people who are left-handed and they are forced to become right-handed by the schools or whatever. So we had to evaluate whether they were naturally left-handed or right-handed. So the participants read 192 words in total, half in English, half in Spanish. The words were presented in a total of 8 blocks, and the blocks follow the following sequence: Spanish, English, Spanish, English, Spanish, Spanish, English, English. And between each block, a resting condition was presented. The word espere after the Spanish blocks and wait after the English blocks. We do this to kind of reset the system with a neutral image or just the word espere, because you can become habituated to what you are looking at. And these are our preliminary results. So what were we expecting? We were expecting to have the L2 students that were not very highly proficient to have their brain work more. So if we compare this to this, what is happening? These are the words in Spanish, and this is the working functional results of reading the blocks in Spanish, and this is reading the blocks in English. So we were really happy, you know? You can see how when you're really trying to understand, or you cannot dominate a language, you have to work more and more and more. And it is very well related to the theory here. However, we found that there is a difficult thing to overpass, and this is the truth. So we have to go back and search for results again. It results that you surely know that in Spanish, the words sound exactly as they are written. Isn't that true? There are no exceptions, except maybe if you're trying to make a distinction between Mexican Spanish and Spanish from Spain. But usually what you see is what you hear. But in English, there are many ways to spell words that sound the same. Isn't that correct? So even if you're learning and you are already beginning to have a moderate or high proficiency in English, you still have to go through the reading of exceptions. You still have to go from the image to the letter and then how it sounds. It has to work more naturally. This is by design, by the origin of the language. So what does this mean? It means that these results do not help us. Okay? We are confused because now we know that English requires more processing than Spanish, even in its native form and with the people who are very highly proficient. So it is back to studying and seeing what we can do again. So Messian and Hernandez found that reading words in English relative to Spanish involved more brain regions in the parietal and occipital lobes, potentially due to the visual analysis required given the many exceptions to the GPC rules. I mean, the exceptions that are in the spelling of the words. Reading words in English requires phonological decoding, given its inconsistent GPC, while reading words in Spanish involves regions related to semantic processing due to the low demand in letter sound mapping. So we have to work more. Future work will center on solving these issues in order to provide a clearer picture on the differences of bilingual, monolingual language processing. Thank you.
Thank you so much, Professor Aspiros. Does anyone have any question? Dude? Okay. We have one.
So, do you have an idea what studies are you gonna do to solve this problem about GPC exceptions and see if your hypothesis was right? And what studies are you planning to do respecting that?
How are we going to solve this problem?
Yeah.
I don't know. No, we have first to study well what will be called native English speakers and seeing how they map onto the cerebral cortex and see if this can be repetitive. So the new hypothesis is that native English speakers will behave like this anyway, and native Spanish speakers will have to work like that. I don't know what will happen with French, because French is also not mapped directly into the spelling and the sound that we're working on. So what we're going to do is have different population, not many, like maybe 20 each of bilingual, monolingual native speakers, and then to see how it behaves.
Couldn't it be looking at different areas of the brain, since you said in Spanish is specifically semantic processing, while in English it is more the spelling? So wouldn't they be different areas that are used?
Yes, that is the next hypothesis. Yes, exactly.
Thank you.
Thank you. We have another.
Dr. Espiros, good afternoon. Have you considered these principles of language acquisition, English as a second language and English as a foreign language? Because it is different. between the acquisition of English as a second or as a foreign language. Have you considered the differences in your studies? And secondly, have you considered the age that those volunteers started learning English?
Yes. Yes, in both. This is while studying to get the English as a second language recognition. It's not like studying English natively or with a family or whatever. This is especially for people who are trying to learn fast the other language. And what was the other question?
The age at the
Oh yes, of course.
when they
Age of
started
ac-
learning the
Age of acquisition is very important. So this is why we only had like young adults in our studies. Is a lot of confusing literature because, for example, we have a group of people who are comparing Russian to English, and there the comparison is weird because the mapping of the words is different. And then you have Chinese, which is a different way of writing. So for now, we are just trying to evaluate the difference between English and Spanish. And then we will see if we get more students and we get money for funding for studying other languages. But for example, French would be interesting also. Thank you.
Thank you. Another question? Comment? Doubt? Thank you, thank you. Please let him clap, please. We give you some little gift for your participation and a certificate of the CBI meeting. Please. Thank you.
Thank you very much.
Thank you. And I have a little gift for the first question. The guy of the first question. Please, it's yours. Thank you very much. With this conference, we close the second day of the CBI meeting. I hope to see you tomorrow at 9 in the morning, 9 o'clock in the morning. Thank you very much and see you later.